everyone, welcome back to my channel. Sorting numbers effectively is crucial in computer science. But what if I told you there's a way to sort numbers digit by digit? That's exactly what Radix Sort does. In this video, we'll break it down step by step and implement it using Java. So let's get started. Here's what will be covered in this video. First, we'll start with an introduction to Radix Sort, where we'll understand the intuition behind this algorithm and how it works. Next, we'll go through a Radix Sort example, breaking down the sorting process step by step. Then, we'll move on to the code implementation, where I'll walk you through how to write the algorithm in Java. Finally, we'll analyze the time complexity of Radix Sort and discuss why it can be more efficient than traditional comparison-based sorting algorithms. So, stay tuned, grab a notebook, and let's get started. Radix Sort is a non-comparative sorting algorithm that sorts numbers based on their digits, from the least significant digit to the most significant digit. The key points in Radix Sort are: it is used only to sort numbers, uses counting sort as a subroutine, sorts digits one at a time starting from the rightmost digit. Okay, let's look at a simple example in Radix Sort, and next we'll move on to the Java implementation of this algorithm. Okay, let's take a look at how this Radix Sort is going to work. So, this Radix Sort is an algorithm that is only used to sort numbers. We sort the numbers from the least significant digit to the most significant digit. Before we dive into the Radix Sort, we need to take a quick look at this count sort because it's the subroutine of this Radix Sort. So, let's take a quick look at the count sort. You can see I have taken an example array here with 6 numbers. So let's get started with the count sort. The objective here is to sort using the count sort to ascending order. We are going to sort this array to ascending order. The first step is to find the occurrences of each number and write it down like this. So you can see number 0 has 1 occurrence, and number 1 has 3 occurrences, and 2 has 0 occurrences, and 3 has 2 occurrences. Okay, after you have created an array like this, we are going to add the occurrences to write accumulately. So we are going to add number 1 plus 3, it's going to be 4, 4 plus 0, it's going to be 4, and 4 plus 2 is going to be 6. So the next step is to shift the array to right by one place. The array we used here, the array we have already created here, we are going to shift it by one place and it's going to look like this. So this 1 goes to this place and it's going to be 1, 4 and 4 likewise. Then we are going to assign the indexes using this created array. So you can see number 0 got the index of 0, so we are going to state here. If you can remember, number 1 has 3 occurrences, so we need to record all 3 values here. So we are going to add 1 to this index. So the 3 ones are going to be placed in index number 1, 2 and 3. Then we don't have number 2 in our original array, so we are going to record number 3, and if you can remember, number 3 has 2 occurrences. So we are going to place this number 3 in the 4th index, and we are going to increase it by 1 and we are going to store it in number 5. So you can see the array is sorted ascendingly. Okay, now we can move on to Radix Sort. Okay, now in here I'm going to take an example array like this, which has 8 numbers. So the step 1 is to consider the ones place. So we are going to consider digit by digit. Okay, so you can see in 170 we are going to consider 0, 45 we are going to consider 5, then 75 we are going to consider the ones place in our array. Okay, then we are going to arrange our array according to these ones place digit. So the zeros is going to be here 0 0, 2 2, then we have 4, then 5 5 6. In this step you need to consider only about the ones place. Okay, after that is done, observe that 170 has come before 90. This is because it appears before in the original array. Okay, the next step is to consider the tens place. So we are going to consider the digit on the tens place. So it's going to be 7 in 9 0, nothing to consider here, 2 4 7 and 6. So we are going to start by 0, 802. Okay, then we are going to move on to 2. 802 has come before number 2. It's simply because it appears before in the original array. So we are going to state it like this. Number 24, then number 45. We are going to consider only about the tens place. So we are going to consider number 0 0 2 4 6 7 7 and 9. Okay, after that the next step is to consider the hundreds place. Okay, so we are going to consider 8, nothing to consider here. Then we are going to consider nothing to consider here, nothing, no tens place, no hundreds place, no hundreds place, no hundreds place, 1, no hundreds place, no hundreds place. Okay, so we are going to arrange these according to our original array. Here we are going to array these according to this array. So it's going to be 2, 24, 45, 66, 75, 90. Then number 1 is here 170, and number 8 is here 802. Okay, now the array is sorted. I hope you got a basic understanding on Radix Sort. So let's break down the Java implementation. First, you can see I have implemented a count sort method here, but I'm not going to go in detail about the code. So let's get started with the Radix Sort. The first thing we need to do is to find the maximum value. Yeah, before sorting we need to determine the largest number in the array, as this tells us how many digits we need to process. So to do that, I'm going to initialize a method getMax, and I'm going to pass the array and the number of elements in it. So I'm going to initialize a variable, and I'm going to think the first element of the array is the maximum. Okay, I'm going to use a for loop here, and we are going to find the maximum number in the array. If array I is greater than the maximum variable, the maximum is going to be that number, and we are going to return the maximum number. There you go. Now let's initialize our radix sort method in here. I'm going to pass an array, the same array, a number of elements. Okay, now I'm going to use m to get the maximum number to determine the digits. Yeah, get max. Going to pass the array and the number of elements in here. Okay, now this part is really important. So we are going to start with exponent 1, the ones place, then we are going to move to exponent 10, the tens place, then exponent 100, hundreds place. We are going to repeat count sort for each exponent until the max number is processed. So we are going to do that. We are going to use a for loop. And we are going to call the count sort. We are going to pass the array, number of elements and the exponents. There you go. So basically that's the method, the radix sort method. Okay, now it's done. Let's see if our code is working. So we are going to move on to the main method, and we are going to first initialize an array. I'm going to use the same numbers in our example demonstration. And n is the length of the array. Now first we'll print our original array. We are going to print it. Let's create a method called print array. We are going to pass that array to the radix sort. And finally, let's print the sorted array. For I equal 0, I equal n, the number of elements plus plus. Yeah. We are going to system out our array. Okay, let's see if our radix sort works or not. Now you can see we have got the sorted array here: 2, 24, 45, 66, 75. You can see now our array has been sorted. This is the original array. This is the sorted array. We have sorted into ascending order. Now you know how to implement the radix sort using Java. Let's break down the time complexity of radix sort. Alright, now let's break down the time complexity of radix sort and see why it's so efficient. Best, average and worst case, the formula appears as big O into D into n plus k. Here's what each term means. D is the number of digits in the large number. N is the total number of elements in the array. K is the range of digits, which is 0 to 9 in base 10. Since D is usually small constant, radix sort performs very well, especially for large datasets. Unlike other sorting algorithms, It doesn't rely on comparisons. Instead, it groups numbers based on their digits, making it highly efficient. And that's how Radix Sort works. It's an efficient algorithm when sorting numbers with a known digit range. If you found this video helpful, don't forget to like, subscribe, and leave a comment below.